Hey everyone, and welcome to the SaaS Developer channel when we learn from each other how to build SaaS applications. And with me today, I have Chinmay Soman, who is today the head of product at StarTree Data. And previously, when I met him, he was a principal engineer at Uber. So he made this journey, which I think every developer should try, from being a senior engineer into being a product leader. And Chinmay, so happy to have you here.
Yeah, thank you for having me, Gwen. Appreciate the warm welcome.
So the reason I invited Chinmay is that I think it was months by now, a few months ago, I've read a paper, Real-Time Data Infrastructure at Uber. And at the time, I recommended it in the SaaS community newsletter. And I finally got an opportunity to bring Chinmay in to discuss this paper. So the paper basically starts by detailing, let me share it on screen so people will know what I'm talking about. So it basically starts out by saying there is 3 fundamental challenges for real-time data within Uber. So can you talk a bit about those?
Yeah, happy to. So as we mentioned in the paper, there's three things that we saw in our journey of building this platform, which took over about six plus years, really, and still counting. The work is still hasn't finished yet. But what we saw are three key challenges as we navigate the waters here in real-time analytics. Number one is data. Data is always growing, as this is an obvious one. No matter whether it's real time or traditional batch analytics, this is data grows exponentially. What is surprising, which may be surprising to some folks, is this is not really correlated with the size of the company anymore. Even small companies are gathering and collecting huge amounts of data. So no matter what the context is, I think this will continue to be a challenge going ahead. Second one is the use cases. This one may not be as intuitive to everyone, but what we saw is, especially for analytics space, real-time analytics in particular, it starts out with internal analytics, where you have your dashboards, you have some key business metrics that are useful for some number of internal users, whether it's ops or PM or exec team and so on. As you know, soon as your business grows and your usage grows, you start seeing product specific analytics, right? So for each individual line of business, you want more details there, which, and this could either be internal or external. So you could have analytics that you're exposing directly to your end users as part of this business, as well as getting more insights into how your product is doing, right? So it's no longer limited to just key system metrics, but also usage metrics, feature store, giving personalized recommendations to your users, and so on. So pretty quickly, what we see is the different use cases have keep on the number of various kinds of use cases and the requirements they bring. They also keep evolving along with your business, and we can get into what exactly those requirements are later on.
We absolutely will, yes.
And related to this is the third challenge, which is the number of users. This was obviously, if I had to pick one, this is the one that kept me up most at night during my Uber days, because and this is where it was a small team trying to support not just obviously build a platform that can scale with the exponential data, scale with the number of use cases we are having, but also the number of engineers we have to talk to. And that was a challenge in the context of Uber. So to give some specific numbers. Initially we started out like with a team of four, trying to onboard. We were onboarding about 2 to 3 use cases per week at the time, and now it's probably slightly more. And then, as you can imagine, in the beginning, there's no automation. So how do you, in the beginning, you handhold people to come up with what is the data pipeline looking like, what should be the schema, what should be the data model, what optimizations you make, and pretty quickly you will hit a hurdle on how do you just cannot scale with manual onboarding. And that's one of the other challenges we saw. How do you automate a lot of these things as you onboard?
Yeah.
Yeah, there
So
you have
you mentioned, sorry, my mind got blank at one or two different use cases onboarded a week, because in the paper, I thought you actually described an unusual number of use cases for a paper, but it's even though it was still like 5 or 6 use cases that you talked about in the paper. How many
it.
use cases did you have?
Oh, I should clarify. Sorry, I didn't mean 1 to 2 use cases. Maybe instances of use cases per week. So, they could still be in the same category. For example, dashboards. But
Mm,
even then, each instance would have its own unique constraints. Whether it's some use cases needed pre-processing done in a certain way. Some use cases needed longer retention. So the specific, the specific team that you're talking to, or within that team, the kind of product or the kind of queries that they were trying to do, those used to differ a lot across the different teams. So this was across, just to clarify for I guess who was listening, uh, this was a combination of use cases around like stream processing, and OLAP. So across the board, we did see a lot of these different variations.
that makes more sense. So before we start getting into use cases, which is really the thing that I'm the most curious about here, um, you talked about manual onboarding and how you have to teach people how to structure schemas, the right way to do processing, the right way to write queries. How is it today? Like with Pinot, is there like a big Pinot book that I can read and will tell me how to structure my schema? Or
Yeah, it's a great. I think it suffice to say the problem hasn't been completely solved, but it's much better than when we wrote this paper. In nowadays, you can there's automation to the effect of uh, data discovery is integrated, so people can go and just click through and select this is the data that I want for real-time processing. Transformations are integrated, so you can pick some limited transformations, whether it's joins between like stream joins, or pre-processing in the sense if you have a JSON payload and you want to flatten it. All those transformations are integrated into the product, so you can you know within 3 or 4 clicks you can set up a data pipeline that can pick your Kafka streams, or pick your CDC streams, define your transformation in a declarative manner, and dump into Pinot, and then test it out quickly in a staging environment, right?
yeah.
So this, we haven't fully automated the experience in Uber, but this has certainly reduced what used to be a week's worth of iteration. It has been reduced to under, let's say, 2 hours,
That's
which is.
fantastic. And I really like how you solved the onboarding problem, not just by writing more documentation, but actually making the product easier to use.
Yeah, because even with documentation, you just have to the iteration still doesn't go away. People still need to actually see something before they want to change and optimize. So it is important to do both for sure.
Yeah.
It certainly want to say that documentation is important, and I think that you can't lose focus on that. But at the same time, make sure you can speed up iteration for your users. I think that is the benefits of that is amazing, to say the least.
Yeah. So going into the use cases, the things that really struck me when I read the paper is different parts of the organization have varying requirements for real-time systems, which are often competing in nature. So when you build a system, you actually had to build a system for use cases that are in conflict with each other.
Yeah.
And yeah, basically, I'd love to hear more about it. And let me stop screen sharing because I know you had some slides you wanted to show about some of the use cases and going a bit more about into them.
Yeah. Let me quickly share my screen. Yeah. So in this we have bucketed the different individual instances into the broad categories of use cases that we saw with respect to real time applications at Uber. So these are the four the big buckets. And there are some more, but these are the four problems. It covers 80-90% of the instances. So the first one being real-time applications. This is typically user-facing. So typically the this is business critical. This is goes out directly to the end users. Hold on, let me make sure my Slack is not bothering our discussion. So an example is dynamic pricing is one example which directly impacts the product in this case Uber ride sharing product or even Uber Eats. There are applications that affect your even revenue in some cases, right? So very business critical, super latency sensitive, QPS sensitive, and has to be tight SLA. That's sort of your real-time applications. Then
Yeah.
comes the dashboards. So dashboards have, as you can imagine, a visual element to it, and this can be again internal or external. So internal dashboards is something only hundreds of either engineers or Uber operators are using, and external dashboards is typically given out to our end users. For example, the restaurant owner, or the if you are ordering food on Uber Eats, then that's our end user. So millions of end users would be sort of visualizing some of these insights. Machine learning is another one. A lot of this is sort of assisting the classic ML use cases, where a lot of the ML use cases are interested in real-time features or feature extraction. This is where the real-time analytics can help out. And then finally, data exploration. This is very limited to the internal engineers or operators, mainly for triaging events and looking at, hey, something happened, let me figure out why it happened in a very quick manner, which is why
Oh,
real-time.
so it have to be real time because it's in the middle of
Exactly.
an incident, essentially.
So if I try to categorize each of these, right, if you boil each use case into the fundamental requirements, it's completely different across these four categories. So, for example, I already mentioned the real-time applications. They have a very strict SLA. So for instance, in case of Uber Eats, the 99 P99 latency has to be under 100 milliseconds, and QPS is in like thousands of QPS on one single Pinot table, for instance. Whereas on the exploration side, um, the QPS is this is human driven, so 1 or 2 QPS at max, and the latency is not. Nobody really cares if it's 100 milliseconds or a few seconds. That's okay, as long as it's not in minutes, right? But at the same time, the query complexity is much higher when you're doing exploration, because you want to be able to join data, you want to be able to run your UDFs or all kinds of goodness ANSI SQL has given us. They want to be able to leverage all of that while doing exploration, whereas the application queries are very pre-canned. They don't change that often. So that's one example of, one is interested more in performance, one is interested more in the query complexity, and they are competing, because to serve complex queries, you may not be able to give the best, like thousands of QPS performance, right? Same thing with dashboards, right? In some cases, the accuracy of queries matter, especially when our exec team was looking at financial data. They were really interested in what exactly is the gross bookings number, right? Once you
Sometimes
give it,
it's even illegal to get it wrong, right? I mean, when it's a public company, you cannot really fudge there.
well, thankfully, this is still an analytical use case, so we were not directly using it from a legally sensitive point of view, but still it had to be accurate. We couldn't get the data wrong. In fact, one funny incident is our CEO at the time actually filed a Jira saying this number is wrong. Back in the day, for one of the products we were maintaining. That's the only Jira ticket our CEO has filed. And so we were sort of privileged to get that experience. But that tells you there are certain categories where accuracy really, really matters. And on the other hand, again, in some cases, it doesn't matter if your aggregate count is 100 or 115. Nobody really cares that much as long as they can get the trend analysis. So, I can talk about this all day, but suffice to say, there's we listed down all kinds of dimensions, right? Query consistency, accuracy, freshness, the ability to do high performance queries, and different use cases would pick a different subset of those requirements, and we had to handle them all. That was
Yeah.
the that's the scaling use case challenge that I mentioned before.
And I have to say that the listing out of all those dimensions may be the most useful, generally useful part of the paper, because a lot of people are very fuzzy around their own requirements. They conflate latency with freshness, even though
Right.
completely separate things. Query complexity versus query flexibility. You can actually support very complex queries if you're allowed to pre-can the results. If
Correct.
you need them to be complex and flexible, it's a very
That's
different problem.
Yep. Yeah, absolutely. Yeah, and I think the we didn't want to build something. We couldn't build a one-off solution for one of these. You could do it at a handful of scale, but this was like a central platform team for all of Uber. So we had to, whatever technology we picked, whatever abstraction we picked, had to sort of work across these different layers. So obviously, fun things to do as engineers.
Yeah, and actually, I appreciated this approach a lot, and I think this is why you may be one of the few teams who even thinks about number of use cases as a scalability dimension, because everyone else, when they get a new use case, they just say, "Okay, let's build a new system for the new use case. Maybe we'll have a pipeline from here to there, but it's going to be a new system for the new use case." And you decided to build a platform that will serve many use cases, often with conflicting requirements, which is obviously a very different level of challenge.
Yeah,
So,
and to be fair, right? Like we weren't presented this big problem at once, right? Thankfully, it grew over time, right? So we had time to sit and adjust what we were doing, right? So you can see over the number of years, the data grew over time. The use cases start growing along with the different business verticals that Uber was adding.
yeah,
Almost every 6 months, we are adding something new, which presented a new challenge. For example, when we started doing, bicycles, this is like with partnership with Lime, or the scooters, right?
yeah,
You could pick. The idea is you can pick a scooter from anywhere. It doesn't. It just shows you on a map a scooter is lying somewhere. You go activate it, use it, and dump it wherever you end your destination, right? Super flexible, but we had to expose the locations in some of these cases. We had to make sure the location tracking was done accurately. So along with freshness and everything, geospatial suddenly became important when that vertical came in. So that's an example where you sort of grow with your business, and you sort of transform your platform for it. So this is what we ended up with, just to show you all the different things we had to do. So this was not built all at once. We slowly started building, one by one, starting with the storage layer, adding streaming to it, and then all the complexities that we added, like stream processing, OLAP, and then a SQL federation layer on top to tie them all together. And what's interesting is, I talk about this in terms of logical building blocks, but even in a chronological fashion, it follows exactly that. It started here in 2014 something, and SQL Federation was done here somewhere in 2020. So it actually lines up with, as grow with your business. That's sort of the theme.
Totally. And then you kind of mapped every one of those use cases to a subset of the abstractions, right?
Yes. For sure. Yeah, we started thinking about, what makes sense for exploratory use cases, for dashboards, and you could follow a different path through this stack, right? So for example, for ad hoc exploration, if this was where, these are engineers who really understand SQL well, uh, and they just need both sort of, they need both query complexity and flexibility on real time and batch data. So they would most certainly end up on the SQL layer, right? So they want access to the real time analytical data, plus all the archive data in Hive, and be able to join stuff across the board. Applications, on the other hand, needed a programming API, where they could many times just call an API to directly tap into uh, output of a stream processing job, or directly tap into Kafka itself, and so on, right? So you could, given a use case, we would pick and choose what do we want for that particular implementation.
Yeah, and as a corollary, I guess, if someone only have one of those use cases, they're just starting out in the real-time journey, and all they need to do is a real-time dashboard. That's it. Then
Right.
they probably don't need this entire stack. They can kind of create something slightly simplified by picking parts of it that they really need.
Yeah, exactly. So if you just want to build for one of these use cases, the good thing is we can now tell you exactly what components you will need in the long run, right? So
Yeah.
we go through that in the section 5 of this, and it talks about, how do you build a happy path for each of these use cases, but also the things that you need for the long running support, like including backfill, including active support, all those included. And also, it's sort of, you can trace the key components in this stack, which
Yeah.
is pretty nice. So you can pick and choose what you want.
Yeah, and you're right that there is another dimension that you don't even see here, which is geographical distribution, and availability is something that you probably had to add for each and every one of those components over
Yeah.
time.
And you're right, like in most like smaller companies, you will not have, you may not have the luxury to build this entire abstraction, right? For example, we leveraged, there was a special team for storage, handling storage, independent team for stream, and independent team for compute on both storage and stream, and so on, right? uh, and so we sort of, we got the knowledge from all these teams together to build these things. But for smaller companies, if you want to build one thing, you can just pick a handful of these things. That's for sure. You don't
Yeah,
need all.
so was that the trick of how you did all this with a four-person team? Because you basically, there was already a Hive team, there was already someone who knew Presto. So,
Yeah, for sure. The 4-person team in that case was the Pinot team, which was supporting a lot of these use cases at the time, right? And we, yes, we depended on, for example, for stream joins, we were leveraging the Flink team, and the APIs they built to get the data prepared in a certain way before it ends up in Pinot. Same thing with SQL Federation. We depended on the Presto team to build the right connectors, and then do all the query optimizations that they did for Pinot. So that
Yeah.
that definitely worked out.
And I have
And
to say that until this moment, I didn't realize that Presto actually lets you join between two completely different sources of data. And this seems like something that is underused in the world in general. I mean,
yeah, I think it's definitely new. I do see companies starting to leverage that. So there's a nice talk from Citibank. They've spoken a lot, or 10x Banking also spoke a lot about this. In their case, they use Trino to federate queries between S3 and something like Pinot. But yeah, Presto or Trino, it's really pluggable. You can easily build a custom connector, and it's available to use as a data source. So yeah, you could easily join stuff lying in Hive and Pinot, which is very useful. For example,
yes.
in many cases, your dimension tables would be lying somewhere in Hive or old some MySQL OLTP data source, and your fact table is either in Kafka or Pinot or something. And doing this lookup join is super easy through the
Yeah,
Presto.
it used to be that you had to copy
Yes.
the dimension table all over the place. It's
Yeah.
kind of great to hear that people no longer have to do it.
Again,
Definitely.
trade-offs, right? What you said, right? That gives you a certain trade-off, especially when you're trying to optimize for QPS and latency. Presto may not be the best option for you, right? Because it's going to scan everything in memory, do the join in memory, which may be prohibitively expensive depending on the use case. So if you're doing an ad hoc exploration, that's totally fine. But imagine doing that for a user-facing real-time application. They're probably not going to go through the Presto route. They will choose some other route in this stack.
So let's say that really, I'm the head of search pricing and I go to you and say, hey, I want to use your amazing new real-time platform and I heard it does all those things. Would you basically tell him, hey, using Presto is not a good idea for your use case.
Yeah,
You need much more reliable latency guarantees. Go copy the data into Kafka and use the maybe Flink APIs if it has the right guarantees for you, something like that.
yeah, absolutely. So what we did is, remember those requirements that we spoke about. We sort of map every single incoming use case into those requirements, and that gives us that immediately paints a picture of what needs to be done. Right? Do we need to do pre-processing, like materialize the results beforehand for supporting higher QPS, or do we want to focus more on speed of iteration, where the schema might evolve quickly, then pre-processing is not an option, right? Those kind of things we sort of got pretty good at once we saw so many of these use cases. So if you ask me in 2014, we would I would not have a good answer. I would say let's try something and learn from that. In 2020, now we have a pretty good handle on this is what you should do.
So the solution to the conflicting requirements that we mentioned in the beginning is basically the platform actually supports all those conflicting requirements by having a lot of different options.
Correct.
And for each use case, you match the available building blocks into their specific requirements.
That's right. So we tried to standardize a lot of things, so it's easy to pick and choose, because in some cases they would start in one category and then move to a different category. The same use case. This happened quite a lot in when we saw people start in real and ad hoc exploration, when they're trying to
Mm.
see what features make sense for my new line of business, right? That may be a PM trying to play around with, hey, there's a new product. Let me play around with what are the metrics I want to that are interesting for me. Once they know, they want to productionize those metrics. And it's not in many cases, you that had to be transparent. You cannot expect the same PM to now choose a whole different set of technologies and a whole different set of abstractions just to productionize those metrics, right? So we tried to standardize wherever possible. So a few things we did was schemas. We standardized on
Mm.
schemas across the board. So right from Hive, Kafka, Pinot, wherever we are storing data, we are always doing like, Avro schema, or we call it heat pipe at the time, and having a centralized schema store across Uber. That was a big deal. Standardized query language in many cases. So we actually bet big on Presto, and even for real-time applications, which is not really uh, will not benefit from the Presto federation that I spoke about. Even for those, we're still we they're still using Presto SQL, which gets translated into Pinot, right? So they don't have to worry about if they switch to a suddenly different set of requirements. The query language is still standard for them, right? This was obviously this is challenging because getting trying to support all the semantics through one standard query across different technologies is super challenging. And
Yes.
right when I was leaving, they were also trying to do the same for the stream processing, right? So initially we had calcite SQL as a grammar for expressing your transformations for stream processing. We also tried to standardize that into Presto. I don't think that effort is it's still going on, but that's sort of the theme of what we like, pick certain things that are well known amongst your engineers or developers, and that can work across many different systems. That helped us a lot in this journey.
Yeah, I have to say that if you told Gwen from 2014 that we could have a single SQL language that would work across all kinds of different systems, I would vehemently object. I would say, no, it will lead to the least common denominator, or you cannot really use the cool SQL features that exist everywhere. So it's really impressive that you guys made it work. And I can see the benefits. As you said, you don't
Yeah.
have to
It-
rewrite everything as requirements change.
yeah. And it is an 80-20 rule, right? So 80% of the time this works, 20% of the time it doesn't work, and we leak abstractions. We have to for those 20% niche use cases, we do even now, I believe they directly use the specific system that they have to, and not use the standard abstraction. That's okay. As I said, right, for scaling use cases and scaling users, if we can automate or at least standardize 80% of the use cases or users, that's a big deal for a small engineering team.
Absolutely. It's extremely impressive. So now that you're in a smaller company and you are the PM who is trying to come up with new features and figure out how people are using his product, are you bringing any of that products that you had back then and using them yourself?
Absolutely. I think what Uber's experience gave us the exposure to all these different combinations of use cases and data pipelines and trade-offs and requirements. That's very useful, right? So now, when as I whether it's a PM from an Uber freight team, or whether it's one of our customers today, I see a very common pattern in what they're asking for. The mental model is still the same, right? What are the key requirements? You map it to that, and you come up with the right solution. And that's helpful, right? So we can we can tell given use case, right? Once we know the requirements, we can say, okay, in this case, whether to materialize or not, whether to materialize a fact dimension join during ingestion time or during query time, right? That's something we can quickly answer. And what's more, we can build solutions around that. right? Which in the product itself. So
Yeah.
something that starts out at ingestion time, we can easily we can support both these functionalities, knowing that people will need it. That is one, and the other thing is just the operational side of it, right? The knowing that creating your table once, the story doesn't end there. You need to do schema evolution, data backfills, corrections, and all kinds of good things. That has sort of also helped us shape the product in a certain way, so that
Yeah.
whatever we do, it should not inhibit these other things. If you're adding a fancy feature, that's okay, but it still should make sure it can do data backfills correctly and schema evolution correctly and so on. So that helps.
But are you also collecting data about how people use StarTree products into a big real-time infrastructure and then run a bunch of ad hoc queries to explore? Or like, do you dog food?
We certainly early, I would say, not as much dog fooding as I would like, given we are a small team. But yeah, I 100%. That is definitely the goal, right? So, for example, just collecting QPS and latency metrics across different customers, and doing anomaly detection on that. So StarTree has a product called Third Eye, which can do anomaly detection, right?
I used
So
it.
it, oh, yeah. So it's great. You can detect statistical variance quickly, week over week anomalies, and these are not easy because it's very seasonal in nature. You can't have simple threshold based alert. So this is something that can quickly tell us if a certain customer has spiked in usage or has suddenly dropped in usage, right? Both are important.
And by
Um,
the way, AWS support absolutely hates that
yes.
because it allows you to get on the phone and like, hey, our EBS was uh, much
Yes.
slower for exactly 10 milliseconds yesterday. And they're like, yeah, we did maintenance, but we didn't think anyone will notice.
That's right. Yeah, there's the opportunities are definitely there, for getting more and more insights into the product. We definitely plan on doing more and more of that, but still early in that journey.
So, with that, Chinmay, thank you so much for joining us and sharing the evolution of a pretty interesting real time data application.
Thank you. Yeah, thank you for having me. Yeah, this it's great to learn. Obviously, shout out to the Uber team and lots of people involved in making this happen, and also the open source communities, right? Kafka, particularly, and Flink and Pinot, those were the sort of the three pillars. A lot of the stuff we built, we got amazing support from all three communities. So kudos to all. This is definitely a big team effort here. So thank you for all.
Yeah. Thank you.